Recording is on.
Okay.
Yeah, I don't think I did any admin since the last meeting, since the sprint.
Okay.
Sorry, are you copying the slides, or do you want me to do that real quick?
So no, go ahead. Put in your info on the slide. Is that what you're asking?
Yeah, I haven't updated them. I'll go ahead and update it and put the new slide thing in.
No, but Abe's got it.
Okay.
He's got it. Paste. See the chat box. Okay, so we've got the new working document, everybody, on in the chat box. Jen, maybe if you want to put it into current meeting, unless Abe, you've done that already. Let's see, is that under current meeting? Okay, Abe already did it. So we're all up to date. Friday, February 26th on the current meeting page on the wiki, so that's good to go. So a few things today. Let's get going. So I'll talk. So we had a nice design sprint on an open source golf cart is the first thing. Just a little update on that. Then there's D3D version 19.02. So I'm still working on further refinements and refinements. I mean, really getting this to the industrial grade, because the promise is industrial performance, fraction of the cost of the competition, etc. That needs to be delivered still. Definitely good work. So with that, got new extruder design. There's also, I'll bring up the concept of called MIG casting, which I'd like to do, and another concept of the heated enclosure, which is actually really good too. I'll bring that up. For Nathan, I got the sample prints. Abe, you saw the the clamp, the PVC clamp. If you wouldn't mind pasting that in the actual picture I sent you, so that we see the physical reality of it. Okay, so let's start with the. Let me share my screen here. So if you wanna, who's recording?
I am recording, and hopefully it'll keep recording.
I am as well.
Awesome.
Okay, so when you record, maybe post to the switch to the window of the speaker or the presenter. So like I'll be presenting a little bit on the slides here. So if you want to take a look at that. Okay, update on an open source golf cart. So it was an interesting meeting. It was decent work. We put together a few, so it's the open source golf cart page on the wiki. So we've got libraries to borrow from, because we've done prior work on things like power cubes and frames. Wow, look at that. We've got the hydraulic motor that's catted up, and that's Katie, who joined us for the design sprint. So look at that. That's awesome. You can download it here. In fact, I will do that just now, because that's looking pretty tasty. And we actually came up with an interesting workflow on that part, where you import images into FreeCAD, and then simply draw over them in Sketcher and then extrude that. So it's a very easy workflow. I did some work on a frame. So the frame's got 3 sides there. Some other modules. But yeah, good stuff. So we were working within the document itself. We'll continue. So whoever's worked on it, please continue to do any of the CAD. And here's, for example, showcasing the motor. Look at that. Excellent. Very nice. And there's an image. Let's see. Do we have... So how we generated this, so Katie, what she did was she took an image from online. We found actual specs of the motor. So these are relatively decent dimensions for what we have for the actual hydraulic motor. I know the shaft is tapered here. It's a straight shaft, but we should have a tapered shaft directly for wheel mount motors. I'm trying to access this image plane here. I'm not sure how that works, but hopefully we can document, get a good instruction on how do you go from the 2D fab or technical drawings, which sometimes you might have to scale. When you start, just get that off the internet. It'll probably not be to scale, so you have to scale it to the proper scale. And from that point, whatever you draw and extrude from that will be the actual part. So that's good stuff. Okay, moving on. So that's the open source golf cart. We'll do another, not this weekend, but week from now, 2 weeks from now, we'll check back in, and by that time we'll do some more work on parts, putting parts into the CAD and see how far we get to the relatively finished design. We can maybe wrap some things up. Okay, so my first report in the team meeting there is continue to work on the extruder. So if you look at that, and let me put a link to this. Okay, there is the link. This is the updated extruder. So moving on and on with refinements and refinements, but what we see here is an assembly that's valid for now the Titan Aero with a Volcano nozzle. Okay, so the former version of the extruder was one for just a regular nozzle. That means you can't do like really big nozzles like 1.2 millimeters or 1.4 millimeters or even 2.0 millimeters. I've seen nozzles that are 2.0 millimeter. But with the former one, the margin, the regular heater block goes up to 0.8 millimeter. This is getting bigger and better. So I designed this on one side, designed a new fan and sensor holder that's integrated onto the front of the existing extruder. So you see on the left-hand side is the print. That's 3D printed. And you can see there's a clamp bolt holding the sensor. So removed the nuts and washers, just did it with this single clamp into a tubular holder. And then the fan, the geometry of the fan shroud is completely different. It's not omnidirectional now, but let me actually get in there and download the file on D3D V1902 page. And I'm actually CADing that all up in FreeCAD right now for the final version. So I'll download OSE Extruder 1902. I'll make a couple more comments about that. It was good in that once I designed the part, I worked completely within FreeCAD around existing part libraries. Like, for example, the sensor, we've got accurate CAD of. The little blower, we've got accurate CAD of. So as long as I was able to generate that well within FreeCAD, it fit perfectly. And so this is the design here without the fan. Let's see, so we can merge the way it is set up right now on the 19.02 page. In the part library, the fan and the sensor are separate files because they have detail, they have threads or fins, which take up a lot of memory. So I split that into two, but into different parts. But if you just download the 8mm sensor, do that, and then download the blower, the 5015 blower, then you can merge that into the FreeCAD file. And it's been saved positionally correct, such that if I'm going to go to FreeCAD and go File Merge, So I'm going to merge my blower right there. It jumps right into place. And then File, Merge, 8mm sensor, and there it is. So that's the assembly. That's the guide rods. That's a carriage piece. But you can see it's I like it. It's cool. Look at that. Just freehand drew up this curved nozzle. Just kind of looked at, okay, here's my geometry of the fan and the sensor, and I just bent it, just drew it freehand in Sketcher, and then extruded it. That's what I did. And printing worked really well. Printed on this bottom side here. So I started the print on this flat side here, where both this ring and these bottom pieces were all on a print bed at the same time. Now, this bolts onto the front of the Titan Aero extruder. So you see this big block here. That's the volcano block. It's the vertical one. It's got more distance. Like if you look, yeah, it's going the long way, so it can heat better. It's called the volcano heater block. Let's see. Where is my... Okay, there it is. That's the... There's that. Yeah, so that's basically the design. It clamps, this assembly clamps around the carriage piece. So the motor is now on top. And then the nozzle, if you look at it, look at the geometry here, it's basically right below the carriage. Because this heater block is longer, you can put the extruder assembly on top of the carriage. Now I have it upside down, but it's just enough so that the nozzle sticks down below the bottom surface. With the other heater block, that wouldn't work. We had to undersling the extruder, meaning below the carriage. Now we put it on top. And therefore the omnidirectional fan shroud does not work anymore because there's no space for that. So just did this new fan nozzle like that, just one direction, but that should be fine. Now, the thing I don't like about the omnidirectional fan shroud is it hides the complete print. If you look at the former version of the extruder, this fan shroud hides everything here, so you can't see how your print is turning out, and you want to see it, like you really want to be able to look at it for the first layer. So that's a definite disadvantage of omnidirectional fan shrouds when they cover the print. This one's on the side, so you can still see the print. Okay, that's about that. And continuing with the full CAD of this 3D printer using a 12-inch frame. So we're using the 12, 14, 16-inch frames. And moving forward. Good. That's my report on that. Second, I want to bring up a couple more things. So thinking about high temperature printing, because there's a lot of, okay, the problem statement on high temperature printing, and I'll, there's a page on the wiki, high temperature heated enclosure. Paste that into the chat box. Okay, high temperature enclosure. So I got thinking about, okay, how do you separate high temperature printing? Because some plastics go really high. Like you can go print with plastics that you have to print at like 400 Celsius on a nozzle, where typically like PLA is 200 about. You can get into crazy stuff where heated enclosure means that the print doesn't warp. That's good for polycarbonate. It enables, for example, polyethylene, polypropylene, which are notoriously hard to print because they'll always come off the bed, they'll warp up. Heated chamber, you have access to a bunch of different other materials. So here's the concept. I just wanted to bring this up because I haven't seen this anywhere. But basically, you've got so this is our new extruder. You got the carriage, and attached to the carriage is a heat shield. And the heated enclosure simply encloses the heated bed. It's not, it doesn't enclose the whole printer, because the idea is if you enclose the whole printer, everything would get hot, and the motors themselves, they can't get more than like 80 degrees Celsius. They'll just burn up. So that's why the enclosure, if you want to print at high temperatures, like this could get you up to like 200 degrees Celsius in the enclosure while leaving everything else cool because it's outside the enclosure. So there's the nozzle, build plate. The enclosure is basically got like felt or fuzz or like, let's see, it would be something like fiberglass boundary between this plate. So the plate moves back and forth. As the printer prints, the plate is moving all over the place, but it's always keeping a seal on top of this chamber. So if you can picture that, there's a chamber that's enclosed. So it will be something like, what would be the material like? Could be some high temperature plastic. One high temperature plastic could, for example, be PEI or whatever, or something like even fiberglass insulated metal or something, where you keep the temperature hot inside, and the bed can still move up and down because you have long slits in that enclosure. So the z-axis can move up and down, but the XY, which is the bulk of the motion there, that's just all riding on the top, keeping that seal closed. As you see, heat enclosure has an insulating wiper on top surface to block heat from escaping around the heat shield plate. So the bottom overall heated enclosure can be as hot as needed as all the components remain outside the enclosure. Take a look at that. This is an easy implementation with our printer. So I'll be working on that as well because we want access to all kinds of printing materials at all kinds of temperatures. So not limited to stuff that's easy to print like PLA or ABS. Okay, that's about that. And the third thing I want to bring up is the idea of MIG casting. So the idea, it's a hybrid idea between a couple of different things. The page the wiki is MIG casting. I'll paste that in. So what is this? It's a hybrid between MIG welding and casting. Say what? Well, the idea about casting is that you have to melt metal somehow. Well, why not use a welder to provide that molten metal? So how does that work? Instead of using an induction furnace or a flame to melt metal, which is messy, you have to have protective equipment like a full body suit with face shield and high temperature shield on you if you're doing that kind of work for safety. But here you can do, this combines 3D printing, MIG welding, and casting. So it's like investment casting where you make a form. So you always have to have some kind of a form into which you pour the hot metal. Here, the idea is 3D print something that you can then later burn out. So 3D print a shape that you want to to turn into metal. Put it into a plaster mold, like, for example, plaster of Paris. So you can take a look at the links on the wiki there. You can look at 3D printing investment casting, which is actually from Lulzbot. That's what inspired this. I saw that and I got excited about this method. And then there's evaporative pattern casting. Look at that up on Wikipedia. And lost shell casting by another guy named Joshua Lecoq. But combine these things together. So you're going to do a 3D print, then put that into plaster of Paris by pouring the plaster of Paris around it, and then you have a mold. Then you burn that out. Or if you have printed only a shell, you don't even need to print that out, burn it out. The weld itself will melt it out. So what you do is you have to leave a hole at the bottom of your form to put in an electrode, because welding works on a closed circuit. You got to close the circuit. You can't just weld into a ceramic because you have to have a ground. So you put in a ground at the bottom, you weld into the container, and there you get a shape such as, for us, what would be extremely valuable is in 5 minutes, if we have this form, take your MIG welder where like a 300 amp welder deposits like about 10 pounds of metal per hour. I was looking at the weld deposition rates. 450 amp welder gets you 17 pounds per hour. You're talking about a lot of metal. So you can do a lot of this stuff. So basically in 5 minutes, if you have the form, you MIG weld into it, and in 5 minutes you can make a metal part that was initially 3D printed. Isn't that sweet? So I don't see why this would not work. It's a combination of where, well, it's limited. This is not good for everything. You have to have access to the weld gun to basically point the weld gun into the top of the whatever you're printing. But things like, for example, 6-spline PTO shaft couplers six spline shafts, couplers that have complex spline geometries, or the drive sprocket for the micro track with an integrated hub to attach to the axis. Complex geometries that can be molded in a mold that has an open face. So there you go. Take a look at that. This would be as fast to prototype. This would be as fast as getting some plaster of Paris, 3D printing a part, making a mold by putting that into like a gallon jug, put the form in there, pour the plastic of Paris around that, and then burn out the form, or leave it in there if it's a shell, and then MIG weld into it. So it would be a quick experiment, a few hours of experiment to see if this actually works. But I don't see a reason why this wouldn't work. So I'll have to try this out, because for simple geometries, they're still, simple, like a spline thing, like still complex, accurate geometries, but limited, and then you can't do like fully closed things where you can't get the MIG welder gun into the cavity where you're actually casting, because the metal, like, it fills all voids, right? But with a MIG gun, you kind of have to point to all the voids with the MIG gun itself. So anyway, definitely we'll try this. This is very exciting, because if you can do metal through 3D printing accuracy, then we've broken the 1 millimeter barrier, any type of MIG gun based additive manufacturing. So very good news. This also lends itself very well to extreme manufacturing workshops, because imagine we've got a busy workshop, we're building a tractor in a day, can get a bunch of people with relatively no skill just doing this MIG welder gun based casting process just with a welding helmet as a protective equipment. So this could really play well with extreme manufacturing workshops, where a bunch of people can readily learn to do this. So very good news. Okay, that's about all I got on my side. That's the kind of update. Let's go to next. Nathan, do you want to go? Or maybe questions, if there's any questions and comments on this, because this is pretty cool.
Yeah, I had a question on the bed and the shield. How would you, if it was like a flexible fabric, like maybe a fiberglass fabric, even a plastic, how would you ensure that as the XY moved, that it wouldn't drag the heat shield into the printed material or move it around? Have you thought about that?
So the nozzle has to be below the heat shield. The prints never go above the nozzle, and the heat shield is above the nozzle, like right above it, right under the carrot.
No, so that's the top of the heat shield, but I'm thinking about the fabric on the sides. So how do you ensure that doesn't drag into the material?
Oh, okay. So the shield moves. The enclosure is stationary.
Okay, got it.
That thing is just fixed to the frame.
Okay, and then so basically it forms like a tent over sort of. I'm trying to figure out the best way to ask my question. So basically okay, I think I understand.
The idea is you have a wiper, like the fixed. Yeah, so that's actually, I didn't specify that point, but yeah, the heated enclosure itself is a fixed structure with a wiper on the top rim, so you're making this glide contact. So something like the top surface of the heated enclosure, meaning the top rim, would have something like fiberglass sheathing or something that's soft, so that the heat shield moves against it, keeping that closed while being able to move.
And the rest of the enclosure is a fixed enclosure.
Yeah.
Got it. Okay. All right.
This is by the way, this is feasible only with printers that have the stationary bed. In other words, the bed is not like typical Prusa printers have the moving build plate.
Right.
And the actual printing axis moves up and down. So you can't do that. It has to be with the system where the X and Y gantry is fixed on a frame so it doesn't move down. Otherwise, you'd hit into the enclosure.
Got it.
So,
okay.
so only the Ultimakers and OSE printers do that kind of stuff.
Okay.
Lulzbot, Prusa, most of the stuff out there is a moving build surface, which to me, I've always whined about that's you can't do industrial grade stuff with that kind of setup. When you have a moving build plate, you can't, for example, print tall objects, which would just shake off the surface if you're printing at any decent speed. So yeah, this design lends itself to much more flexibility and quality. And it allows this enclosure, which kind of dawned on me. I was thinking about this after I put the extruder on top. It became obvious that, hey, now you can enclose whatever is below the entire axis assembly because the extruder is way at the top. It's not like hanging below. So it became somewhat obvious that just the nozzle is sticking out, and therefore you can enclose that whole build chamber.
Yeah.
Which I haven't seen. This may actually be patented. I know there's a patent on heated enclosures out there. I haven't looked into it much, but I don't think it matters because we could innovate around it if this is enclosed already. No pun intended. But because we published this here, this cannot be enclosed anymore unless it's already been enclosed.
Got it.
Yeah.
Cool.
Cool stuff. Okay. Because the wiki license is called CC by SA, so whatever's on the wiki, that's prior art for, and it's got a timestamp on it. So
nice.
There you go.
That's great.
Yeah. Any other questions on a heated build enclosure or the MIG casting? Okay. So definitely worth trying. Those are low-hanging fruit experiments that can be implemented pretty rapidly. So see when I can get the time. I'm working on building the printer with an overslung extruder, the new extruder. So once I have that, maybe just build the enclosed box around what's below it. We'd have to mount the heat shield somehow. That's not considered in the current design. So definitely would have to redesign just to mount a plate of something. I was thinking like a good material for that heat shield would be, for example, PEI, which is a high temperature plastic. It melts at like 400 Celsius or something like that, 450 Celsius. So that would be a good material for heating. And it's also transparent, so that would work. It's the same stuff that we have on a build plate, on a build surface, the stuff that makes prints stick to it. And when it's cold, they pop right off. Like, for example, here in my house, I'm not heating this part of the house. When you finish the print, typically you have to wrestle it. Well, if you don't have PEI, you definitely have to wrestle it. But with PEI, it's supposed to come very gently off the surface right away. Well, in this case, it literally popped off by itself because it was near freezing weather. So that PEI stuff really works for getting the prints off, which also means a good thing for automatic part harvesting because you can simply bump the finished pieces off with a bumper to collect them. So you could have like 24/7 automated printing, just part after part. Finish a part, bump it off. Finish a part, bump it off into a container. Things like that. Okay. If no more questions, we can continue with Nathan. Do you want to continue on stuff? So I actually printed. Let me actually share the screen here. So I did make a couple of prints.
Okay, great.
So let's look at my screen here. I mean, these are tiny prints, but yeah, I mean, the result is, so first of all, like you print them, they're like literally, they're pretty glossy on the bottom. pretty much come right off the build plate. As I said, it's pretty cold in here. I'm wearing a jacket, not heating this house here. We're at the other section of campus. But the report on this is, I mean, the feature sizes are tiny. It's definitely small. Like when I actually touch it and feel the, how tiny the little magnets would be, I mean, you'd really need tweezers. And I can tell you that they're going to be jumping around. The holes aren't, I mean, yeah. Getting down to, because these things are like 3 millimeters diameter, and the depth of the side holes is like 1.5 millimeters, I think.
Yeah,
super
exactly.
tiny. Like, I don't see this happening. So what are we gonna do? I would say, what if can we double the size of these magnets? I mean, we have to make something bigger. Like, for example, also the little pinholes, like you see this, you have like the Lego block, like little protrusions.
Yeah.
There, that are supposed to fit in the corresponding holes at the bottom because these two pieces are supposed to snap together.
Yeah.
Two pieces are supposed to snap together with the magnets in between. Yeah, they don't really fit. And if you see like the size of the feature, it's way smaller than the bumps on Lego blocks. So yeah, I just can't get that accurate with a printer at this stage. What do we do? So maybe try to convert this to 6 millimeter magnets. Can we do that?
Okay. Yeah, we can definitely give that a shot. Can you, so your screen resolution is kind of low, so it's kind of hard to see the detail on those. Can you just take a picture and either post it on my log? Yeah, probably just post it on my log. So basically double the size of the
magnets.
Of the magnets. Okay.
Which is not a problem for the flat laying ones.
Yeah,
but for the ones with edges.
Yeah, the ones on edge.
Just make it so when you close it, the magnets really like hit to the side. That's fine.
Okay, got it. So so my main concern is for the walls so those are the 6.5 inch thick walls. So basically for the exterior walls, we have some thinner walls that are 4 inches for interior walls. Do you want me to make the magnets hide? Do you want me to design it such that the magnets hide in the 4-inch walls as well?
And use the same magnets?
Yeah, using the same magnets, but basically making the design on the 6.5 inch walls larger than it needs to be to accommodate the 4-inch walls.
Yeah.
Okay, got it.
I have a question.
Yeah, go ahead.
So you talk about the magnets jumping around. Did we talk at all about possibly putting ridges or fins? I don't know how detailed the printer will get inside the holes, so that like when you put the magnets in, it moves the plastic. You know what I mean? So like if you put thin fins inside the holes, like little tiny ridges, then when you put the magnets in, that'll kind of create a tight fit for the magnet, so they won't jump around as much.
Yeah. I mean, that's kind of what we're trying to do, right?
Okay.
That's that's news to me. Is that what I should be?
Kind of like lips? Kind of like, I don't know, what are you talking? Where would you put those ridges? Because I mean, you got to insert the magnet. Where do the ridges go?
Well, if you put really thin ridges inside the holes, then when you put the magnets in, it ostensibly would like bend the plastic if the ridges are thin. I don't know how thin the 3D printer can get. Yeah, but that's like really common for fitting things together. So they'll kind of break down as you put the magnet in, but it'll hold the magnet.
Yeah.
I have no idea.
But then you're taking up space that the magnet has to go in, and the space there is tight enough already.
The plan is to glue the magnets like usual, right? Is it?
Oh, it is to glue the magnets, but I'm telling you, before you're going to glue them in, they're going to all jump at you.
Yeah. So you have to have a pattern or jig.
Physically, it's just very difficult to get them all. Like if you have 2 magnets, fine. Maybe you can do 4. But like, beyond 2, it's tough. And some of these pieces, we're going to have more than 4 magnets, probably like 8 magnets in a piece or something like that.
I'd have to go to fast contact glue or something like instant and do 1 magnet in 1 piece of plastic at a time. Because those are tiny things. So if you're making a lot of those at once, right? So you just glue 1 magnet and then keep cycling while the glue dries.
Yeah, and that process takes forever, unfortunately. We've done that kind of stuff. So, we have to basically be able to get the magnets in there, have them hold by themselves somehow until we're ready to, because in principle, we actually wouldn't necessarily even need to glue them if they're inside these double sandwiches.
There's no room to make the holes a little bit bigger to account for the fins then, for the ridges inside?
Yeah, I'm having a hard time seeing how you can get the resolution on that ridge because whatever you're going to print, it has to be like absolute minimum is like 1 millimeter. You can't really do like a ridge, like a thin thing that's like less than a millimeter, really.
I gotcha.
Yeah.
Is this something that we can mold? Could we do like molded plastic?
Well, yeah, but that's totally different. Totally different technology, though. That gets into the idea of that you have molds that you then squish molten plastic into, but the molds are expensive. They're metal typically, and that's the reason why 3D printing is good, because you don't need those molds, right?
I was wondering about doing like 3D printing, it wouldn't work for these, like 3D printing a form and then filling with plastic, but I don't know if it would be hot enough if it would necessarily be so hot it would melt the plastic when you filled it.
If you're using something like the PEI plastic, which is printable at very high temperature, you can possibly use it as a mold for stuff like PLA or some other things which are at 200 Celsius for their melting point.
Yeah, like filled with a lower temp. Yeah.
Yeah, I don't know. I haven't heard that, but that could be possible if you have some high performance plastics that are really high temperature. That would be doable. But then again, if you're not going to be able to get the resolution issue, which I think is what you're driving at, because you're printing with a 3D printer.
Isn't the resolution, if it's not that accurate, if you're printing, I guess, that fast, or isn't there a certain amount of texture and roughness to the 3D print as it is? There is, yeah. I guess you're saying it's not super accurate to a millimeter. Is that mostly just because of the print speeds and or the nozzle type?
Yeah, like we can do smaller nozzles. Like, okay, this was 0.4 nozzle. You can go down to like 0.25 nozzles, tighter layer resolution. You can get more detail, but I mean, just after I've seen this, I can tell you I wouldn't want to be messing with those small magnets. So I think let's start by going to a little larger size. Like, first of all, like these tiny magnets are so tiny that you can hardly pick it up between your fingers, And when they're so strong, it's actually going to be difficult to take 2 of them apart because your fingers are so big compared to the size of that magnet. I mean, it didn't really occur to me until I finally printed these out, and these things, I mean, the features in them are very, very small, to the point that you definitely need tweezers. And how do you take 2 magnets apart with tweezers? I don't know if it's possible.
Martin, I was thinking about it. What if you kind of 3D printed a part that's basically like, just like a stick. It has a little hole in it that you glue a magnet inside, and then you can stick that on top of your stack of magnets and then slide it off.
Yeah, you can. And then if it holds in that structure that you put it in, that'll be good. But if it doesn't hold, it's kind of devils in the details on this. But to make it simple, like as a first step, let's enlarge it.
Okay, got it.
No, I mean, it was interesting with so we were using 12 millimeter diameter magnets for the former versions of the 3D printer, but people just really didn't like it because you have to hold like you have to be very careful when you're working with that, because you have to hold all of them out. You have to redo it, and people just ended up hating it. Everyone said, let's get rid of the magnet. which I was like, oh, too bad. They're kind of cool, but it's dexterity wise, it's not easy. And
Yeah,
especially if
got it.
people don't have good dexterity, it's going to be like really frustrating.
Just like before the workshop, tell them all to grow their fingernails out a little bit.
Yeah.
All right.
But no, this is cool. I see promise in it's like, yeah, I mean, look at that. My new house right there.
Yeah, totally. Most definitely.
That's
all right.
what we could model. We get some windows and doors, and there you go.
Yeah, I mean, before, because that's a lot of more design work than kind of the simple designs I've been working on. So I just wanted to make sure that the design was solid before we proceeded. So I will just
you mean with the little house model.
Yeah, exactly. So I wanted to get the feedback before I started working on the doors and windows.
Actually, it's as simple as that. And think about it, like imagine we have this modeling kit of buildable panels. It's something that literally anybody can do. So it's good. I mean, it might look ridiculous, but no, it's not. It's, if you think about doing basic functional stuff, like a lot of people can't even do that, what you showed there, right? Because you have to have some skill. But if you show a pattern of how you can do that exactly with these modules, then literally anybody is able to do that. And I think that's really valuable.
Yeah, most definitely. I mean, like it seems like what's good about this project is that it's like if people start doing it, it's like really accessible to kids, and so you have high user adoption, and so you basically like you're kind of leveling up sort of the public on in terms of like sort of, I guess, OSE literacy.
Yep.
And so you basically have young people who are eager learners, who are starting kind of at the basics. Yeah,
I agree with you. And I am still very excited as I start talking about the curriculum aspect, but, we have all our complex stuff, but curriculum wise, offer this as a kit for students to do FreeCAD, to do real design, like little additions to the set and all that. So we can definitely put some attention to getting this into schools for people to make meaningful stuff. Because I know in school, of course, we don't do a lot of practical stuff, but this could be an example of really practical stuff.
Yeah, most definitely.
Yeah. So maybe the next step would be just, redo one that's doubles the size. Just send it over to me ASAP, and I'll just print it out, get your feedback real quick on that, how that's looking.
Sounds great. Should I just share my screen for the rest of the group to?
Yeah, go ahead.
And show them what I've worked on. Okay, cool.
And whoever's recording, grab Nathan's screen.
All right. So I've basically, let's go back here. These are sort of like I've worked on all these sort of flat, easy parts for the library. Let me just pull up a file in FreeCAD. So this is the wall module. Oh, oops, sorry.
Yeah.
Let me see here. Sorry, let me download the right one. There we go. All right, here we go. So if we look here, you'll basically see like I made it so that you can put the magnets in flat. And so if you have walls that are connecting to other walls in a like so walls running perpendicular to it, the walls can run into it at pretty much any point every 6 inches, I think. I mean, 6 inches in the real world. And then on the edges here, I basically put these same magnets in that you can put them in vertically, so that basically you can have two walls butting in perpendicularly to each other. And then you print off 2 of these, flip them around, and stick them together. That's what these things are for right here, and these little cavities, so that basically you can print off. It's the same part, but you print off 2, and then you have a full 6 inch. A full 6 inch wall, and the the reason we're doing this is so that the magnets are totally hidden. And then we have other things like we have, let's see here. We have our roof module, and that's pretty similar. I changed the design around a little, so these have 4 positive things where they all stick together, so that when we print off this, it doesn't have any positive. Doesn't have any positive, I guess you could call them Lego connectors, so that when you print it off, there's no tilting on the bed or anything like that. So it's pretty simple. And so this is for the 12-inch thick roof module. But yeah, basically same technology. And so creating all those holes is kind of tedious. So I just basically wrote a Python script to automate that. And so it's.
Can you show that script? Where's that script? So that's on your log here. Okay. Can you? Yeah. I'm going to download it. Let's see if you can explain it. So the way, just so we start getting familiar with how scripting works in FreeCAD. Mm-hmm. So let's see.
Yeah, let me go ahead and open up the script here.
Yeah. So it's .py in FreeCAD. So what do you do with it? So you open up FreeCAD and then what?
You open up FreeCAD. So let's see, I'll open this up I like Sublime text editor. That's like by far my favorite text editor. Basically, okay, so I'm pretty much reverse engineering this. I'm not great at Python or just scripting in general, but basically anything you do in Python, if you go to view, here, I'll close this. If you go to view, and you go to toolbars and you workbench toolbars. Shoot, I'm not sure where this is on my Mac. Basically, view. Do you know where the Python?
So view toolbars. No, I don't know where it is.
So view panels and then Python console. So basically, like any action you take in FreeCAD. Let's see here. Toolbars.
Yeah, the console at the bottom. It's tools, view.
So basically, any action you take in Python, it'll print out the actions in the console, and so then basically you can recreate any actions you take in FreeCAD by just copying and pasting that back into the console.
Right.
So what I did is I ran through. One, sort of one whole model, and then kind of like made some loops to make all those repetitive holes. And then I basically set this so that you can basically put in the dimensions of your can you see my screen?
I can only see a small picture on the side, but whoever's recording, are you capturing the full screen? Abe and Jen, are you capturing Nathan's screen?
Yeah, I don't think that there's a choice with the Jitsi. I think it just automatically does it. Whatever screen's up gets recorded.
Okay. Can you guys see Sublime, my text editor, with all the Python code?
Yeah, I can't read it though.
Okay, yeah, that's fine. Here, I'll blow up the sides.
But are you basically cutting and pasting from the Python script into the Python console within FreeCAD?
Yeah, basically.
Okay.
Here. And this might be here. So for example, I'll make a 4x8 wall. Create a new document. And then I just, paste in here, and then, automates all of those holes for me. It's probably going to be a little bit different on Mac. So it's not as impressive. What you should see is an entire 4x8 panel with all the pockets automated, but I don't think you'll see that. That'll be on Linux. But basically, you can automate all of your panels with all the holes, and then you can subtract from there to kind of get your windows and everything like that.
So, like for example, the logic in there, like while loops, like while evaluate X condition,
Yeah,
stuff
sure.
like that, like all this stuff. So you did that, like that.
Yeah.
Did FreeCAD generate that?
So basically, all of this stuff, like to here, that's all in FreeCAD. And then I did this so that I created a definition called add circle, and that's just adding a circle. You give it, 2 variables, X and Y. Those are your coordinates. And then I created this, and then I get my conditions. So, like sometimes when you create a sketch, there's it's like on a negative y, and negative x, and sometimes it's a positive y and positive x. So you kind of have to get your conditions so that basically it's flexible for all the different orientations of your sketch. And then let's see here. Basically, so here you go. Like here's adding a circle, for example. So basically, for as long as y is less than the height in millimeters, you basically add a circle. So so until so basically it's like vertically you add circles until y is not less than a certain than the height, and so then you stop. So
and you define your height and width and all that initially?
Yeah, I define that all the way up at the top. It's kind of messy just because there's a lot of FreeCAD stuff that you kind of just need. Do you want me to comment more clearly in my code so that people can actually
I mean, what would be useful is like FreeCAD script 101. Like, can you do like how we have the working document for the dev meeting? Can you do like a little document that explains how you did that and how to modify it? So we can
Sure.
Kind of like a little lesson that it's very specific to OSE, but then others can build upon it and we can actually kind of follow what you're doing a little more.
Yeah, most definitely. Do you want the video to be high density, or do you just want it to be kind of like a slow tutorial? Because like you have high density videos on the FreeCAD 101.
Right.
And so what do you prefer?
Well, I think don't use a lot of dead space. No,
Okay.
I just
I mean, because yours was I was really surprised at how much information you fit in there, and I think your philosophy behind it is really powerful.
Well, the truth behind that video, it takes 1 minute to 1 hour ratio of editing.
Yeah, no, I do not doubt it. I was pretty impressed. But so do you want me to do strive for something similar to that?
Yeah, strive for something that's dense because I mean, we can always look up stuff on the internet and stuff. Like, I think a lot of times it's important that people get the overview of what's going on like pretty quickly. So, because it's really about repeating it, just going through it again and again until you really get it.
Okay, got it.
Yeah, that'll definitely be my style.
Okay, cool. Yeah, I can definitely work on that. That'll give me that'll give me something good to work on. Sort of while we go back and forth on the 3D printing designs. Perfect.
Yeah, that'll be good.
Okay.
And it only takes like right now, one of these pieces, 20% infill. It's like 25 minutes for it's 2 inch by 2 inch for the squares that I did, and the panels will be 2 by 4 inches. But really, it's like when you think about the scale, is 1 millimeter to 1 inch about in real life.
Yeah. Pretty much.
Because the 25.4
Martin,
millimeters to 1 inch, so it's about 1 millimeter.
Yeah, real close.
The real scale is 1 to 24, right?
Yeah. Mm-hmm. I had one question.
Yeah.
About my design. So in the guys, let's see here. I wonder. let's see here. In the let's see here. In the project that you shared with me, where the guy has the sort of interior design kitchen.
Yeah.
I know you can't see my screen, but maybe the people who are recording can.
Yeah, I can somewhat see it in a small picture. Yeah.
Instead of printing it as a solid, they printed it kind of like they have internal, like it's sort of like a web. So I imagine that would take up a lot less 3D printing time.
Yeah. Yeah.
Would you like me to work on something like that, or should I just do it
No,
solid?
you don't have to, because that's
And then we take away from it.
no, that's covered by the slicer. You select what percentage infill it has, so it's not dense inside. It's actually like honeycomb.
Ah, got it. Okay.
Yeah, and
Okay.
I did this at 20%, so it's a lot of honeycomb inside. 100% means solid, but 20% is pretty light.
Got it. Okay, so that's all covered in the slicer.
Yeah.
Perfect. Too easy.
Yep.
Okay.
But there is optimizations you can do later on, like like if we're actually doing rigorous production engineering on this, there might be places where we don't need the insides at all, so just print, design the shell in FreeCAD, and then when it slices it, you have 20% with the empty space inside because you designed the empty space inside, stuff like that.
Got it. Okay, so it sounds good. Are there any resources for 3D printing on the wiki?
There's not a lot. Like the curriculum is not there, but Appropedia. So let's look at this, because there's actually pretty good stuff from the Michigan Tech Open Source Sustainability Tech with Dr. Joshua Pierce there. Okay. So appropedia.org, and let's find this real quick. 3D printing tutorial, 3D printing curriculum. Let's see. 3D printing curriculum. What they've done. 3D printers education. Let's see.
Can you share your screen, Martin?
Yeah.
All right, I'm going to stop sharing my screen.
So appropedia.org/3D printers education. Is this the place we want? Yeah, that is. I'll paste the link. And we want to prepare something, like kind of adopt that for us. I haven't taken a look at it that much. We're going to kind of refactor it for our purposes. I guess they talk a lot about their printer. There might be some other page on there that, see, there's design software, education tools. They have a link to See Me Educate 3D printing curriculum. Let's see. I think there was something else on Appropedia besides this page. Oh yeah, there's actually, I think, a 3D printing course. Let's see. Let's see, MTU classes. There's some course at MTU, Michigan Tech University, that was dedicated to 3D printing. I can't find it. I'll take a look at that. I'll get back to you on that one. There's, let's see.
Okay. All right. Sounds good. I was just wondering if there was kind of anything like similar to the I guess FreeCAD 101 thing, where it was just like, here's a bunch of like good best practices for 3D printing, just things to keep in mind, or here's like 3D printing with FreeCAD or something like that. But okay, cool. I'll look through that wiki. It looks like there's a lot of stuff.
Yeah. Okay, we'll find that another time. Okay, continuing here. So good work here on the clamp. So you're doing some more work. We got a crazy clamp. Okay.
Yeah, okay. My connection, unfortunately, was a little spotty. So while Nathan was talking, and so I missed some things, but hopefully there'll be some other recordings are better. But I think I see what you were talking about on your log and so on. I was kind of looking at some FreeCAD macro code stuff as well earlier. Kind of after the design sprint, there was, let's see, some question about I guess the issues with it was partly really the tracing, but I was looking at how difficult it was to make a sketch with rounded corners, and so I was trying to see how hard it was to constrain that stuff, because I think some of the issues we were pointing out with the Sketcher was getting the things constrained for parts so that they're accurate and so on. So I think that was an issue with the design sprint. But
tell me more about the idea of this crazy hole for the PVC.
Yeah. So the email, it sounded like you were saying from the photo. Actually, was what I was trying to figure out what in the email. And what I was trying to figure out what you meant by that, and I think I understood. It's like you're suggesting maybe making the clamp a little bit asymmetrical, or part of it would be shaved off. Like in the photo, you've inserted a bolt there, I think, or you're pointing in there with a bolt, or on the bottom left. But I think you were trying to say that one was if one was shorter, so it would be if the parts weren't the same, that it would apply a different clamping force. I think is kind of what you were saying.
But no, I meant a different thing. So look at the look what I just did on this. If you take out that part, just shave off a little bit. Do you see what I'm saying?
So the issue is it's because it's symmetrical. If I shave off a little bit, it'll just be shorter. I was about to do that. I was like, I'll shorten this side, but actually it just, because it's the same part, unless we do two separate parts, it will it'll just make the clamp shorter, right? Because
it's just very minimal what you have to take out. Really
yeah, minimal. I guess
you just need some clamping.
I thought about changing the shape of it that way. If it was shaped different, maybe it would do differently. But idea with the changing the inside hole, it might be more adaptable and compress more if the hole had some teeth or something. And I just started scribbling, trying to get that to something, and it messed up some other things, so I have to redo some sketch stuff there. But it looks ridiculous, but having teeth in there would reduce some of the plastic in the bulk part and make it flex, and that might make it clamp better. So
yeah, but you need clamping distance. So that hole, compared to what you have right now, if you make it slightly smaller, it would provide that clamping activity. Slightly means like 1 millimeter larger, smaller diameter.
Just a smaller hole.
2 millimeter diameter.
Yeah, I take it that you put it on like a furniture leg there. I take it that looks like it's about 3/4 like PVC, because I made that hole the actual diameter of the specs for the 3/4 PVC. I just
Exactly the
left
same?
it at that. Yes, it was 5.
Can you start maybe by
5 to
taking?
5.
Okay. Can you do a version that's like 1 millimeter and another version 2 millimeters smaller?
Yeah.
I think
yeah,
that could do the trick. I mean, all we need is just a little bit of clamping.
Yeah.
Because right now we don't really have any clamping. We're just relying on the fact that they're just the same size, pretty much. You know,
hmm Yeah.
to get
yeah.
a nice. It fits well, actually. It doesn't slide
Yeah.
offhand, but I think it will slide down.
Yeah, so I'm wondering how flexible does it feel? Does it
No,
you
it's
think it's
not
gonna?
flexible. It doesn't feel flexible
No.
unless we're printing this out of flexible materials.
Yeah. Okay. So it's pretty
So,
solid then.
pretty
It doesn't seem like it's pretty sturdy. I guess the parts
Yeah.
that are thin aren't too thin or anything like that.
No, they're good.
Okay. Okay. Yeah.
I
Because
put the bolt in there just to show that it's that's how it clamps on. It's just a demo.
okay. I guess just making it a little bit a millimeter or two smaller, that would be a good start. Yeah. I figure having I don't know. The teeth thing would be hard to figure out what exactly they should be shaped like. So yeah, making it
Right.
well, what
That's gonna help.
size they should vary from. Yeah, I mean if they're a millimeter over and under, but by adding the teeth, you make the whole thing maybe more flexible, and so some of them stick past the original shape or the actual PVC, and some of them, I was trying to draw it just in general how I thought it might be efficient, but yeah, it would make it more flexible, but it would be so variable, it would be hard. So yeah, I'll make it with a radius, it shouldn't have
You know
to
what?
vary much.
But
So
tell me why you don't like the idea in the red.
see if I make it shorter.
But you're not making it
far-
shorter because the hole is already accommodating. Like the hole will not allow you to make it shorter. That space will appear there and it'll be just pinch space. It wouldn't make it shorter. You're only be
Okay.
making it shorter by the amount you pinch in
Yeah.
a little bit.
I would have to adjust the shape. Yeah, just right. So it would kind of bend the thin parts in towards. Yeah.
Yes. Yes.
Yeah.
But you don't need to make any modification outside of trimming off just a little bit, like 2 millimeters there.
Yeah.
I think that's easier.
As long as
Because once you start reducing the hole size, then you don't have a good fit on the actual PVC.
Yeah. Yeah, I'll have to adjust the shape of that a bit so that it doesn't actually shorten it. Yeah, it has
If
to
you
be
do
an
what I
odd
showed, it doesn't
shape
shorten
change.
it though, because the hole constrains it to that same distance, doesn't it?
Yeah, I think so. It would fit, and then maybe there'd be a gap even at the PVC. Yeah, I guess I see that. So yeah, I can
a fixed
try
hole
that.
there.
It'll be easier.
Yeah, it's not going to reduce. That hole will keep it the same spread.
Yeah. Okay. So I'm gonna look at.
Yeah, do that one. I'm telling you, that's going to work.
Yeah.
I've seen that with like working with metal. I can tell you that it's the wing structures, which is what you're creating here, is like wing structures. That kind of stuff works well. But once you start changing the diameter of the like a shaft and a tube for the shaft, that the bad fit just makes it not really work well because you don't have good contact.
Okay. Huh. Yeah. So
metal. I'm sure it's going to be like the same in plastic here.
Teeth won't provide enough friction. Yeah. Or, well, they might flex too much and then not hold well. Okay. Yeah. Let's see what else.
Yeah. Yeah, just a minor trim. That's a quick job. You just do a sketch on that surface and trim it.
Okay. Make that a little bigger. Yeah, I started to do some stuff on it. I made a repo to put some FreeCAD macros on because I was working on stuff to make that go faster. Because I noticed a lot of these things that we draw a lot in FreeCAD, they some of them are a little hard and there's a lot of time spent. And plus, when I was trying to make the FreeCAD macro, the sketcher was behaving a little, as it gets more complex, it wasn't behaving very well. And so that's exactly why you kind of need to make out. It's more helpful to make some of these macros for commonly drawn shapes and so on. So I'm going to try to do a little more of that. But
Nice.
I've noticed too, you have to refine the code a lot by hand sometimes too, or you have to think out how you make the macro and record it ahead of time, because the behavior of the program can, get it where you make a lot of mistakes. You have to manually edit the code if you know how, or you just have to re-record it more than once. But either way, I'll try to get more stuff in macros of that kind of thing uploaded, and I think that'll make it easier. Save some time anyway, and people. I found that often working and looking at with other sketches, I've learned a lot from that, because I think people first starting out, they don't know how to. The best way is to start out drawing things, and you can learn a lot of tricks just by looking at other people's examples and sketches and things like that. So I think the macros kind of do that too, because you can make like a generic macro that draws like a symmetrical shape, and then it may be even faster to go in and edit that into a slightly different shape than it is to just draw something from scratch. And that give also people something to look at and learn kind of how some things are done. So.
Yeah.
Yeah, I think that's mostly it. Oh, on the golf cart in general, to continue with that, I was trying to simplify the seat and that kind of stuff. I started to draw, I think, some sketches in the golf cart document. I think I linked that on my slide there, or yeah, golf cart doc. So I started sketching stuff in there because I had been changing the CAD a little bit. And I started on slide 5 because I was trying to think of how to make the bench seat that I was working on more, not just simpler, but maybe that module itself could be simplified by making it integrate and just weld into the whole frame. So probably design it a little different than I had started to. And I know we were worried about it being flexible and all kind of things, but if the frame is just like a big cube, which yeah, makes sense. I mean, it's not like this thing needs to be aerodynamic. It gives you lots of space to put stuff in the vehicle. So I was trying to think how to make some braces and just tie it in with the rest of the frame. So I think it'd be good to have I mean, maybe that's not a priority, but it'd be good to have more discussion and maybe just sketch some things up. It's almost faster just to draw things out on paper sometimes, and maybe share photos. But if we get a better idea of the measurements, because all the parts are inevitably related to the other parts, so until we set certain standards, which I guess that the outer frame size, that's kind of fixed, so everything else needs to just be drawn to fit inside of that. But
yeah,
I think there's probably still questions about like the roof and how we cover everything and all that. So it's kind of hard to decide what to do on the CAD, or we just end up making lots of changes if we don't have enough specs set kind of to know what to do exactly.
Right. We got to start fitting the parts into the final CAD to see how things fit together kind of iteratively. All we know is the frame size is a certain size, and we just declared it. Make things fit in there for now.
Yeah, so on the frame, do you think you've got a cube kind of started for that? Do you think you want to make it more trapezoidal and kind of refine that shape more? I mean, obviously it's going to need more.
I can't tell without putting on motors and wheels and stuff.
Yeah,
like
it's going to need
cube. We got to see how to put in it.
It's also going to be a little more complicated, yeah, because it needs more bracing and things to mount things to. So I guess that the question is just the motors, motor mounts, all that stuff. So
yeah. I also have a question on the clamp still though. So I'm looking at the picture we had in the work document. I'm looking at page 8 from before. No, page 7. I'm noticing that so the nut catcher is no longer inside the clamp. You had a nut catcher inside the clamp before, right? This version here on slide 7.
Oh, so let's see, in this document 7, there's a nut catcher on, let's see, on this clamp. On the current clamp, to get it short enough for the right. Yeah, I thought that'd be an issue. For the short side, I figured the nut catcher on the current clamp on one side, obviously there's a deep hole.
Oh, I
But
see.
on the other side, there's well, that photo you're looking at there is messed up. But so let's see, in the clamp normally that you printed, the nut catcher on one side is very thin, because I couldn't obviously recess it through that thin part there, if that's what you're referring to.
But we're addressing that because the nut catcher is going to be in the 3D printed piece.
Yeah, well, obviously there's nuts on both sides, but the axis bolt that's longer, it bolts through and it recesses over there. So yeah, I figured the question would be, there's a question of which side the nut goes on or the bolt goes on, which I think it's easier to put the nut in the 3D printer axis part, right? And then push the bolt through, except for on the thin one where the nut, it might be easier to put the nut on the outside and just have it be in that short recess, and then the nut would stick out. Of course, it could be the other way, and the head of the bolt is going to stick out on that thin side, just because there isn't enough space. But I don't think it'll be in the way of anything that I can see, because you can just face it towards the outside, and then it doesn't interfere with anything, best I can tell.
Yeah. No, okay. I was just questioning that part, but no, that the nut catcher part is addressed. Okay, thank you. I'm trying to open up. Are you still doing work on the PVC full frame assembly or mini PVC? See, 1 week ago you'd made some.
I haven't reassembled anything to that because, I think I updated the funnel clamp there, and I don't know if I updated that into the main file. I thought some of that, but it needed to be, I think, kind of restructured because it wasn't quite updating automatically. But I need to do a lot more assembly there. And let's
test how the clamp work and go from there.
I'll adjust the clamp first. Yeah.
Yep. One thing at a time. Excellent. See what we got here. Yeah. Okay, I see. Get some of the. I see. Yeah, you put in the updated clamp into the assembly there. Yeah. I mean, it looks pretty good. I mean, cool thing about it is, like, the clamps are 3D printed. We can print the corners and the tubes even, so very much largely 3D printed. Yeah, that's good. All right. So next, let's see if anyone else. Do we have any reports from anyone else?
I haven't heard back from any homeschool programs. I'm going to try to find time to follow up on that this next week, but I might be completely sidetracked preparing for the hackathon and filling out our stuff on Democracy Lab.
Okay.
So I don't have any update besides meeting Chris, which was amazing.
Yeah.
And he's getting me set up with some environment.
With some what?
With some new Python stuff, so I can do more self-study and get places.
Yeah.
I'd set new environments, helping me organize stuff. And he said he'd help me I don't know, wrap my head around the hackathon thing.
Yeah. Yep. All right. Cool. All right. So we've got a few things in progress, from the housing to the new printers and the PVC clamps, the open source golf cart in the works, and moving along. So yeah, we'll continue work on this. So yeah, let's take it away until next Tuesday. So we'll do the meeting next week, and then follow up design sprint on the open source golf cart after. Okay.
Martin.
Yep.
I had a quick question. This last week, I had an idea that I think is pretty cool, but it was basically like where people could start up sort of like micro maker spaces in their own, like, for example, like a garage or something, like where they could say, okay, I'm gonna like provide a space for people who want to do 3D printing. And so they, build like an OSE 3D printer, and then for people to like gain access to the space, they need to like do some design work or learn FreeCAD or things like that. And then you could basically have it so that you build up like social currency, almost like a cryptocurrency or something, so that you can then like buy, I don't know. So like if you learn FreeCAD, for example, you get like, 20 bucks or 20 OSE bucks or something like that. And so you kind of gamify learning this stuff, like, again, sort of like striving for OSE literacy. And then at the same time, it allows people like in their community to build things that, for like, I don't know, like things that people can actually use in their community. So it kind of really at like a really basic level starts alleviating that sort of artificial scarcity. And then as it grows, then like one person's like, oh, I've got some more space, I'll have a foundry. Or another person's like, oh, I'll have a wood shop. Or another person's like, oh, I'll have a gardening center or something like that.
Yeah.
What do you think about it?
Well, it's great. I mean, someone's got to do it. For us here, we've got our facility, and it's still about getting, building, build it and they will come kind of deal,
Yeah, for sure. Okay, cool. I guess like
you're thinking about starting something like that yourself?
Yeah, I mean, I guess so. I'm looking at maybe looking at a job or something in Austin, Texas, and I just kind of, I want to do something along these lines, and I'm like, well, I guess start where you can,
Yeah.
So I guess like if I were looking into something like that, would it like how like would you want to be OSE affiliated, or would it just be totally on its own but use OSE technologies? I mean,
it would be great if we coordinate, like, have people join the development team. The bottom line, I think, is in getting real products out there that can work. Like, for example, if you're working on the house modeling kit, getting that to a product is the prime thing. So for you, I think it would be pretty important to get your hands on a printer so you can really keep working on this and make it into a decent packaged product, because that could be like now you could create your own CDCA home prototyping activity around that. Making kits, selling them.
Cool.
Be good.
Okay, nice.
Yeah. It takes time, but I think the number one thing is to have packaged products. I mean, that's where like our trouble is right now, is we don't have packaged products. We're working on packaging some things, but that's the thing that we really need to do, because that's going to get the financial feedback loops happening when we can actually put like buy buttons on our website and can get revenue coming back, because that's we haven't worked on that so much throughout the history. We've done a lot of workshops, but we got to package products of all sorts. So really put attention to enterprise development aspects. Yeah.
Okay, got it.
Yep. All right. Well, that sounds good. So I think that's good for today. Thanks everybody for participating, and yeah, we'll take this next week again, Tuesday, 2 p.m. Central Time. So thanks a lot, everybody.
Thanks, Mark.
Thank you.
Yeah, thanks everybody. Good meeting.
Good meeting, and yeah, send on the recording.